Hi, my name is Joachim Nyström, your contact at SSAB for ships, offshore and energy-related applications. I will here in a few video sessions show you possibilities of increasing your competitiveness using high-strength steels from SSAB. In this particular part, I will focus on using high-strength steels in dynamic loads. First and most important, it is to understand the load situation, the load spectrum and cycles of the dynamic load. In fatigue situations, surface quality and edges is much more critical compared to in static load cases. So you need to ensure the quality of surface fineness and whole edge quality. Local stress concentrations are also critical in fatigue load cases. When you do a design, you cannot have very stiff parts meeting a very flexy part. It is important that the whole structure dance together and you don't have this stiff part meeting flexy part, because then you will have a load concentration where these part meets. So it's important to have an equal flexibility throughout the whole design. In a fatigue situation, you need to have good control over the welds, because often the welds are the most critical positions. The best would be to remove the weld from the most critical area. But if you cannot do that, there is post-weld treatment that can improve the weld performance in a fatigue situation. These graphs show how fatigue strength is dependent on surface fineness and strength of the material. On one axle you see the strength of the material, and on the other axle the surface quality. The polished part can make good use of the high strength of the material. If we compare a normal 355 plate, you see that the fatigue performance is about 270 megapascal. If we then increase the strength from 355 to 700 with the same type of surface quality, you will reach 335 megapascal. If you then increase the surface quality to 10 microns instead of 30, then you will increase the fatigue performance of a 700 grade up to 420 megapascal. So this means that you can make a weight reduction of about 20 to 40%. In dynamic loads, the challenges are often related to joints. The pathway to increased performance is to refine, replace or remove these joints. In this application, you see the weld going all the way up to the area of the beam where you have the highest stress. If you instead move the weld to the center of the beam, you will have 8 times better fatigue life. In this second example, it is an agriculture example from a plow, where in the first case these details are welded, and in the second example the details are bolted into the main chassis, which will give a significant better fatigue performance. In this third example, we are not removing, we are not replacing the weld, we are just refining the way the weld is done. So instead of starting and stopping in the edge where it is most critical, the start and stop is moved outside the edge, and that will increase the fatigue life with up to 5 times. If you cannot replace or remove a weld, you can use HFMI treatment to the weld, and by that enable a 50% weight reduction of the structure. So what is HFMI? High frequency mechanical impact. Basically, it is cylindrical intenders that are hitting the weld toe with high frequency. The result of the HFMI treatment is an improved geometry of the weld toe, and it will also introduce compressive residual stresses in the weld toe that will prevent a crack to appear. HFMI treatment is suitable for most common weld methods and all steel grades, and can be done manually or by robot. It is not very complex. So, let's look at some results. This is the recommendations that IIW have done investigating the performance of welds with HFMI treatment. If you look at the standard 355 grade with a common normal butt weld, the FAT value is 71 megapascal. If you have the same grade and do an HFMI treatment to the weld toe, the FAT value will go up from 71 megapascal to 112 for FAT class. Upgrading to a 960 level, you see that you can increase not only 4 FAT classes but 8 FAT classes. And you can go from 71 megapascal up to 180 megapascal, more than double. So again, upgrading from a 355 grade to a 700, or in this case a 960 grade, using HFMI in a fatigue load case, you can reduce the weight by 20 to 50%. If you think this is interesting and you want to learn more, please feel free to contact me at joachim.nystrom@ssab.com.